Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, in the last session we learned about the Rutherford's model of an atom and the experiment which leads to the discovery of nucleus. We also learned about the drawback of Rutherford's model of an atom, that the major drawback or defect of a Rutherford's model of an atom is that it does not explain the stability of the atom. Yes, in order to explain the stability of an atom, Niels Bohr in 1913, a Danish physicist, explained the causes of the stability of an atom in a different manner. So let's start with the Bohr's atomic model, which describes the stability of an atom in the different manner. So in this session, we are going to understand three interrelated topics. First, the Bohr's atomic model, then the arrangement of electrons according to the Bohr's atom model, and then the electronic configuration of electron. So let's understand first the concept of the Bohr's atom. So according to Bohr's, let's write here Bohr's atomic model. Right? So according to Bohr's, there's a nucleus that is a positive nucleus, and this is the orbit in which electron revolves in a very fixed path with a fixed energy. These are the electrons. So this is proton and neutron in nucleus, right? This is the electron, and these are the orbits, or you can also say energy levels, right? Or you can also call it energy shells, right? So this is basically the structure of an atom according to Bohr's atomic model. Friends, you must be knowing that electron is a negatively charged particle, proton be the positive, and neutron is the nil. That is, it doesn't have any charge, it is a neutral. So due to the proton, the nucleus contain the positive charge, right? So here electron have certain energy, which revolves in a fixed circular path, right? So here if you see, the structure of an atom is just like an onion. If you cut the onion, from middle of the onion you will see the rings like this. This is an onion and this is an atom, right? So now if we talk about the energy of an atom, the electron, basic energy of an atom is due to the electron. These are the different orbits, We call it 1, 2, 3, 4. We can also name them by letters like K, L, M, N, and so on. It depends upon the size of an atom, right? So if we talk about the energy, when electron in the fourth orbit jumps towards the nucleus, what happened to the energy? Energy is released, right? That is, energy of an electron decreases. And what happened when the electron in the third, or you can say M shell, jumps to the outer shell, that is N, or you can also call it fourth shell? The energy is absorbed. That is, electron gains energy, right? So this is basically the energy of an electron, how the electron increase and decrease the energy. For this you should also know the electron closer, you can write here, you can note the electron closer to the nucleus have the minimum energy, right? So this is basically the concept of Bohr's atomic model. So let's understand the concept that was given by the Niels Bohr. That is, according to him, when an electron is revolving in a particular orbit or a particular energy level around the nucleus, the electron does not radiate energy. That is, it does not lose energy, even though it is accelerated motion around the nucleus. That is, when it is revolving in the fixed circular path in the one orbit, it does not radiate energy. It does not, that is, the energy does not changes. When energy changes, when it jumps towards the nucleus, that is towards the shell or the orbit of the nucleus, or goes out to the outermost shell or the orbit, right? So let's understand now the Bohr's atomic model, that is the concept given by Bohr's. First is, an atom is made of three particles, electron, proton, and neutron. As electron have the negative charge, proton positive charge, and whereas the neutron have no charge. So they are neutral basically. So due to the presence of equal number of negative electron and positive proton, the atom on the whole is electrically neutral. Second, it says that the proton and neutron resides in the nucleus of an atom. Yes, as due to the presence of proton, nucleus is positively charged. Third, the electron revolves rapidly around the nucleus in a fixed circular path. We call it energy levels also. Fourth, the energy level can be represented in two ways. First, by numbers, that is 1, 2, 3, 4, 5, and so on, depending upon the size of the atom. Secondly, it can also represented by letters K, L, M, N, O, P. That is, each level is associated with a fixed amount of energy. It also says that there is no change in energy of an electron as long as it revolves in the same orbit. As I have just explained you that there is no energy in the energy of an electron as long as they keep revolving in the same orbit or the same energy levels, that and the atom remains stable. So the change in the energy of an electron takes place only when it jumps from a lower energy level to the higher energy level, or when it comes down from a high energy level to the lower energy level. So when an atom gains an energy, it jumps from lower to higher, and when the electrons come down from high energy level to lower, it loses energy. So friends, let's see now what is the arrangement of electrons in an atom according to Bohr's atomic model. So this is a figure which will make you more understandable. See, this is a nucleus, positive nucleus, right? Containing proton and neutron. And these are the orbits or shells, right? So electrons are negatively charged. So electrons basically resides on the orbits of the atom, like this. So we can also represent by KLMN or 1, 2, 3, 4, right? So first energy level, this is the first one. We also call it K shell. This is the first energy level, right? This is the second energy level. This is the third one. This is the fourth. Friends, K will be having the minimum energy and N be the maximum. As you know that electrons are negatively charged, so they form a cloud of negative charges outside the nucleus. In this cloud, the electrons are arranged according to their potential energy in a different energy levels of shells. As we have denoted here 1, 2, 3, 4 KLMN. So the energy level in the shells are represented by circles around the nucleus. The shells are counted from center to outwards, right? Like I have done here in this figure. 1, 2, 3. As closer to the nucleus is the lowest energy level. Now I hope you have understand the energy level and the diagram of the atom according to Bohr's atomic model. So let's discuss now how these electrons are arranged in these shells, these energy levels. Let's explain. So friends, we are here to see the arrangement of electron, right? The two things we should know about the electrons, or you can say the atom of the element, that 2 points we should always know when we are going to see the arrangement, that we should know the atomic number of the element. Second, we should know the maximum number of electrons that can be accommodated in the different shells. The atom. Why do we want to know the atomic number of the element? And why should we know the maximum number of electrons that can be accommodated in different shells? Why? To see the arrangement of electrons in an atom. What do we call this arrangement? We call it electronic configuration, right? So this is basically a process to know how the electrons are basically arranged in a particular atom, or you can say the shells. That is, the arrangement of electrons in various shells of an atom of an element is known as electronic configuration of the element. So how should we know? How do we configure the electrons in an atom? For this, we have to understand these Bohr's and Bury scheme. Now, what is this scheme all about? So, according to this scheme, there's a 2 points. First, the maximum number of electron present in particular energy level, you can call it shell also, is 2 into n to the power 2, that is 2 into n square. So, for example, for the K shell, that is the first energy level, you have to write like this. What is n? N is nothing but the energy level. So here is first. So the answer comes out to be 2. That is, 2 electrons can be accommodated in K shell. Right? Let's do it the calculation of all these shells. So for L shell, that is the second energy level, 2 into 2 this, which comes out to be 8. Similarly, we should calculate for the M shell, that is the third energy level. This, if we put into the formula, it comes out to be 18. And for N, it comes out to be 32. That is the fourth energy level. Right? Thus, the maximum number of electrons that can be accommodated in the first energy level is 2, for second level is 8, for third it's 18, and for fourth energy level is 32. Right? So now the first K, we can also write here the tabular form. KLMN. And the electrons which can be accommodated in these shells 2, 8, 18, 32. Right? This is the shell. This is the electrons. And the second Bohr's Bury scheme says that the outermost shell of an atom cannot accommodate more than 8 electrons. Even it has the capacity to accommodate more electrons. Why? That is, in other words, the outermost shell of an atom can take a maximum of 8 electrons only. So for example, if M shell is the outermost shell of an atom, so then it can hold a maximum of 8 electrons only, though its maximum rated capacity is 18 electrons. Thus, this is due to the fact that having 8 electrons in the outermost shell makes the atom very stable. You should note this point. Why does it happen? Just due to the fact that having 8 electrons in outermost shell makes atom more stable, right? I hope you have understand this particular point. So here we can label down the electrons also. So K will be having 2 electrons. Let's put 2 electrons here. In L we have 8. 1, 2, 3, 4, 5, 6, 7, 8. In M we have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. In N, it is 32 basically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. So the second Bose-Bury scheme says, according to an element, the configuration which we do when we see there is an outermost shell keeping the electrons 8, we have to take the electrons 8, and then we have to fill the rest of the electrons in the outward shell. That is, we have just taken the example that M shell is having 18 electrons. That is, it can accommodate 18 electrons, but it is the outermost shell, so we have to keep only 8 electrons in that. We can take this by the example, but first we have to note this table. It will be more handy for you to understand. That is the electron shells and the maximum capacity. KLMN shell with the 2, 8, 18, 32. So friends, we have to understand the second point. So let's understand by taking a special case of potassium, which have 19 as an atomic number. Friends, you must be knowing that what is atomic number. It's not nothing but the number of protons. And we should know for a stable element, the number of proton is equal to the number of electron. So if we know the atomic number, we can also know the number of electron present in the element, right? We can write here number of proton, and since the stable, therefore the atomic number is equal to the number of proton is equal to the number of electron. So now if we make the electronic configuration of potassium, it comes out to be 2881, right? We can also take the example of calcium, which is 20, KLMN, that is 2882. So here you can see we have filled the M shell with the 8 electrons only. To make the element stable, that is the atom is stable when the outermost shell contains only 8 electrons, right? So why this is so? As the size of an atom increases, the energy levels of the shell gets closer together, and immediately the fourth energy shell or the energy level N overlaps the third energy shell M. So the M shell can accommodate maximum of 18 electrons, but when its shell contains 8 electrons, overlapping occurs. A maximum of 2 electrons are added to the N shell before the M shell continues to fill up again. So here you can see the first and second Bohr's scheme applies to this example. That is Bohr's and Bury scheme. I hope this example is making you more clear about the electronic configuration. So now let's make the conclusion for the whole topic. But before, I think we should look for the example. Let's take a very easy example to configure the electrons in an atom of an element. Let's take there's an element X with the atomic number 12, which means X has a 12 electrons. So first of all, electrons will go to K shell. Let's make in a diagram. This is 12p and 12n, the positive charge. So this is my K shell. This is my L. And this is my M. So what will be the configuration? KLMN. First I'll put 2 electrons into K. Then how much left? 10. How much KL configure? That is the accommodation of L shell. Let's write here. It was 2, 8, 18, 32, right? So how much we left? So 2 electrons are left, which will be accommodated by M shell. So this is the configuration, that is the electronic configuration of X element with the atomic number 12. So let's put this into the diagram. This is my K, this is L, and this is M. So let's put the electron, 2 electron to K, then 8 electrons into L shell, and the rest 2 into M. So this is the electronic configuration and of element X. So now we conclude the whole topic. First we conclude that the Bohr atomic model, which says that the atom contains electron, proton and neutron, where these two resides in the nucleus of atom. It also says that the electron revolves in a fixed energy level, or say orbit. It also says that the energy levels can be represented by 1, 2, 3 or KLMN, so on. So it also says that there is no change in energy level of electron if it is not changing the orbit, right? It also says that when an electron jumps from, let's say, K to M or K to L, electron gains energy. An electron comes towards the nucleus, electron loses energy, right? It also says the K is the minimum energy level. That is, the closer to the nucleus, lesser is the energy, right? So energy increases like this. So friends, I hope you have understand this conclusion part, and the whole topic. So now let's have some activity. You just have to solve all the textbooks problems related to Bohr's atomic model. That is, you can make all the electronic configurations of at least first 20 elements, so that it will be more easy and more effective for you to understand whole topic. So friends, we'll meet in the next session with the valence electron. Thank you.